you guys. It's really great to be here, and I have the challenging task of going last after these amazing presentations. So I'll try to do it justice. As Wendy mentioned, I'm talking about using problem identification construction to determine the possible. Just a little bit of sort of understanding my thought process and where I'm coming from. My training is in industrial organizational psychology, so I'm concerned about organizations and also coming to this from the perspective of creativity. While that's not the focus of this talk, this is where I started, and you will see that a little bit throughout in terms of merging the possible with creativity and thinking about problem identification construction in that context. So first of all, just a little bit about problem construction. You will see it in the literature in various names: problem definition, problem identification, problem formulation, problem framing, problem finding. There probably are a few more that I'm forgetting. But I personally prefer the term problem construction because there's something very active about the word construction. The person is constructing actively the problem to be solved. And I'll talk about what problem construction or all of these mean in a second. And as I mentioned, it's extensively studied, or not extensively, it's studied more often in creative problem solving, and unfortunately not extensively. There's a lot of room for more research on this. So what is problem construction? First of all, we need to recognize that a problem exists. That is not always a given. Just like Samantha mentioned, we have these chance meetings, but they're not always an encounter. We need to recognize there has to be this intentionality to some extent. A great example of a recognition that a problem exists is in the development and identifying of penicillin. So for years, scientists tried to grow bacteria in petri dishes. There were petri dishes where nothing grew. There was this mold, and they basically put those petri dishes in the trash and called them errors. It took Fleming to look at this and go, wait a minute, why is this happening? And what can we learn from it? So he took a situation that existed and posed the question, recognized a problem. And as a result, we have penicillin. But we also need to then construct the problem. That is, what are the parameters? What are the elements that guide future problem solving? So those two aspects are really at the heart of problem construction. Now, it's important to understand that many problems are ill-defined. Ron talked about the ambiguity that is associated with the lack of structure. And I'm going to argue that problem construction allows us to provide some structure to that ambiguity. And hopefully the kind of structure that Ron is talking about, where it's not too much, but not too little. When we talk about ill-defined problems, we're really talking about problems that can be viewed in multiple ways, depending on your perspective. They have multiple possible solutions. Here's that word again, possible, and have multiple causes. Depending on your perspective, depending on what you attend to, some solutions are going to rise up to the top for you. Other people will have different solutions. These are problems that we typically talk about in terms of better or worse solutions, but also depending on what your goal is. And because they are ill-defined, because they are ambiguous, they require some structure before we go into problem-solving mode. But they also allow for possibilities, which is why, to me, this is an important aspect of connection between problem construction and possibilities. When we look at a model of problem construction, which we developed, published in 1994, The first step is that attention to environmental cues. Again, as Samantha mentioned, we see a lot of cues. We don't always attend to them. You cannot identify a problem, you cannot sense that there is a problem that needs to be solved if you do not attend to those environmental cues that signal that there is a problem. Go back to the penicillin. People just ignored it. The cue was there, but people ignored it. Borrowing from cognitive psychology, problem construction is based on problem representations, which are cognitive structures. Problem representations are developed based on past experiences. You solved a problem, and now you store in memory a representation of that problem that includes what were the goals of the problem solving, any constraints that may have been placed on the problem solving effort, what information you needed to solve the problem, and the procedures that you used to solve the problem. And that is stored in memory and gets elicited every time you see a problem with similar features. But note that it is based on past experiences. So if you have not encountered a problem before, you will not have anything to base this on. And different people with different experiences are likely to see problems in very different ways. So studying problem construction, for most people, most of the time, problem construction is automatic. Most of you don't sit down and go, I wonder what the problem is. Let me think about this. We just automatically assume that we know what the problem is. Where you really see this is when I study teams and they start arguing over what the right solution is. And all of a sudden they have this light bulb moment where they realize that they're trying to solve for very different problems. And that's why they're arguing over the solution. Their problem construction is different. Because it's automatic, it becomes really hard to study. So a typical approach to elicit problem construction was developed by John Baer. And basically we restate the problem in as many ways as you can, starting with how can I, how can we, which is incredibly helpful. And now I'm going to show you what problem construction might look like. So again, borrowing from Baer, the statement of the problem is there are mice in my basement. My apologies to those of you that don't have basements, but there are mice in my basements. A very simple problem, right? One sentence, a short one at that. Nothing like the complex, ambiguous problems like trying to deal with a global pandemic. So how can we restate the problem? So one restatement is, how can I catch the mice? Now, if I'm asking this particular question, this leads me to a very specific solution, right? The phrasing of the question, the way I structured the problem, leads me to think about a mousetrap. But I can also think about, how can I prevent the mice from getting into my basement? That leads me to a very different solution or solution set. I need to think about identifying how they're getting in and sealing those areas. If I think about a mousetrap, it's not going to prevent mice from getting into the basement. If I'm thinking about sealing the basement, it's not going to do anything about the mice that are already in there. It's really that combination of both of these that provides me with a much better understanding of the problem and potentially a much better solution. But this is not all. So when I use this example, my psychology students were very quick to say, how can I not be bothered by the mice? Maybe the mice and I can coexist. Maybe I need to go to therapy and not worry about the mice. And then when I presented it in our College of Business, they said, how can I make money off the mice? And this to me was one of the better solutions. They developed an idea for a mouse circus. Okay, so they're going to use the mice in the basement. The point is that even a simple problem, there are mice in my basement, that is nothing like the complexity of the problems that we're facing, can have multiple perspectives and multiple possible ways that we could think about it. We just need to allow ourselves to do that. We need to give ourselves time to do that. So what do we know about problem construction? The early research, the kind of the forefront of the research by Getzelsen, Csikszentmihalyi, looked at art students. They asked them to create a still life painting. So they gave them different objects. They observed them while they were developing their plan for what they would paint, what objects they chose, how they arranged and rearranged those objects, how long they took to do that. And those were their problem construction measures in addition to some others. And then they evaluated the originality and aesthetic quality of the painting and found that they were related. In addition, problem construction metrics related to success as an artist 7 years later, both critical acclaim as well as financial success. And if you've done longitudinal studies and you try to correlate something with something that happens down the road, whether it's 2 years later or 5 years later or 7 years later, you know how difficult that is. So that's pretty impressive. So they were the first ones to really talk about problem construction, problem finding, and identify that as an important aspect of creative problem solving. A little bit of a summary of the literature. In terms of what we know, a lot of the early work really focused on creative individuals and experts. So in Getzelsen, Csikszentmihalyi's work, they found that creative individuals spend more time engaging in problem construction. Voss et al. Studied experts and found that experts spent about 75% of the time allotted to them for a problem-solving exercise, defining what the problem was, whereas novices spent 75% of the time actually trying to solve the problem, and not very successfully. After that, the literature moved to sort of looking at problem construction ability as a more stable individual difference variable that was related to creativity. And again, we find that problem construction ability is related to creative performance at the individual level. There are two meta-analyses that looked at problem construction. Ma in 2009 looked at problem construction as one potential predictor of creativity across multiple other predictors. Abdullah et al., which was just recently published, is specifically focuses on problem construction. And both of these studies found that problem construction was the best predictor of creativity, above and beyond, or did better than divergent thinking, did better than intelligence, and other metrics. So problem construction is important for creativity. More recently, we found that active engagement, so instead of looking at problem construction as an individual difference variable, let's try to make people engage in the process by asking them, for example, to generate these statements of how can I, how can we, or training them in problem construction. That improves creativity. And we have found that the quality and originality of the problem construction itself predicts the quality and originality of the solution that was generated. So it's not enough to actively engage in problem construction. The quality or the creativity of what you do in that process directly affects the creativity of the solution that you generate. One of the things that this is a study that we are working on to get into publication, but I think it directly relates to possibilities, so I wanted to bring it up. There's this concept of paradoxical frame, which basically says that if you give people a paradox, that can lead to increased creativity. But the contradictions inherent in a problem must be identified first, right? So here's that attention again. You can't just view the problem from one perspective and not attend to the others. What we have found in our own work is that when a problem is restated in a paradoxical way and participants use those restatements, those paradoxical restatements, don't ignore them, then we see increased creativity. But we also find that participants are very willing they generate paradoxical statements of the problem, but they're willing to ignore the paradox because it's difficult. So instead of thinking about the possible ways they could solve for multiple and paradoxical ways of thinking about the problem, they choose to ignore portions of it and focus on potentially what is easy or what they already know. So I want to conclude by talking a little bit about problem construction and the possible. I kind of alluded to it throughout the talk, but really to me, problem construction process is the identification of the possible, right? We get an ill-defined, ambiguous problem, and our job as a problem solver is to identify where we're going with this. What is our goal? Those are possibilities. And we can truncate our possibilities at this very, very early stage by ignoring certain aspects of them, or we can open things up, as with the paradox, by attending to multiple perspectives and ways of thinking about the problem. Even in the whole concept of problem representation, we have two pieces that are directly related to what is possible. The goals tell us what is possible. The constraints tell us what is not possible. And what we're finding as we talk to people and as we analyze our data across multiple studies is that sometimes people view constraints that are not really there. So it's one thing to say, okay, I was given a budget of $10,000 to do this project, it's $10,000, versus you were not told what the budget is, but you're assuming that the budget will be $10,000. Right? So the other thing that emerges through the problem construction process is questioning constraints and assumption, which is another way to open things up for the possible. And with that, I'm going to stop here. And here's my contact information. If for some reason you have additional questions later on, happy to answer. And I think we're